Hello students, we are solving the IB Math AHL past papers and currently we are solving the IB Math AHL May 2021 paper 3 time zone 1 past paper, and today we will be solving the question 2 of this paper. So without any further delay, let us start with our today's session, and you will be getting the links to all the previously solved questions in the description area in form of playlists. So, question number 2. It contains maximum mark of 28. This question asks you to examine various polygons for which the numerical value of the area is the same as the numerical value of the perimeter. For example, a 3 by 6 rectangle has an area of 18, 3 times 6 is 18, and a perimeter of 18, because 3 plus 3 is 6, 6 plus 6 is 12, 12 plus 6 is 18. So the area is 18 and the perimeter is also equal to 18. For each polygon in this question, let the numerical value of its area be A and the numerical value of its perimeter be P. Subpart A, find the side length S, where S is greater than 0, of a square such that A is equal to P. That means the area of the square will be equal to the perimeter of that square. And it contains 3 marks. Okay, side length is S. Therefore, area will be equal to S square and perimeter will be equal to 4S. Okay, and because A is equal to P, because A is equal to P, therefore S square is equal to 4S, or S square minus 4S is equal to 0, and taking S outside the bracket, making it the common factor. It is the common factor of these two terms. So within the brackets, we have S minus 4 equal to 0. Therefore, S is equal to 4, S is equal to 0 or S is equal to 4. Since S is greater than 0 given, because if S is equal to 0, then you will not be having any square. If the side length is 0, the square will not be existing. Therefore, S is equal to 4. See, it's so very easy. We have got 3 marks. Okay. Moving on to subpart B. Before coming to the question of the subpart B, we have something given. So, an insided regular polygon can be divided into incongruent isosceles triangles. Let x be the length of each of the two equal sides of one such isosceles triangle, and let y be the length of the third side. See, they have given the isosceles triangle. This is the insided polygon, regular polygon. So this is one of the isosceles triangle, and the two equal sides are having x units length each, and the third side is having y units length, and the included angle between the two equal sides has a magnitude of 2 pi by n, because there will be n isosceles triangles. It is a n-sided regular polygon, so you'll be having n isosceles triangles. And since the total angle around this point will be 2 pi, it will be getting distributed between the n isosceles triangles. So each vertex angle of each triangle will be equal to 2 pi by n. So part of such an insided regular polygon is shown in the following diagram. We are seeing that. And now coming to subpart B, it is saying write down in terms of x. X was the side length of the equal sides of the isosceles triangles. And n is the insided regular polygon that we are having. An expression for the area AT of one of these isosceles triangles, and it is containing just one mark. Okay, so I can write, I can do the working over here so that you can see, and I can write the final answer besides the question. So since we have to give the area of one of these isosceles triangles in terms of x and n, forget about in terms of what, we will be just first of all getting the area of one of these isosceles triangles. So the area AT will be equal to half times x times x times sine 2 pi by n. Okay, so this is half x squared sine 2 pi by n. This is the formula for the area of a triangle, the trigonometric formula for area of any triangle. And for an isosceles triangle, these two are equal, so it is x and x. So now I just write this final answer over here. It is in terms of x and n. It is containing x and it is containing n. So let me write the answer over here. Just copying. AT is equal to half x squared sine 2 pi by n. Okay, we have completed answering subpart B. Moving on to the next subpart. Subpart C. Show that y equals 2x times sine pi over n. So what is y? Where is y? This is the y is the side length of the third side of this isosceles or any isosceles triangle. This n-sided regular polygon has been divided into n number of isosceles triangle, and this is the third side of any of the n isosceles triangles. Okay, so we have to get the expression of y in terms of, you see, in terms of x and n. So fine, let us first of all, instead of just worrying about how to express y in terms of x and n, let us try to find the expression of y. Okay. For that, I am dropping a perpendicular from this vertex of the isosceles triangle on this third side. Okay. And since this is an isosceles triangle, a perpendicular that is dropped from the vertex onto the base of an isosceles triangle bisects the base. So this one will be y by 2 and this one will also be y by 2. Okay. So now let us find the expression of y by 2. If we can get the expression for y by 2, we can multiply that by 2 to get the expression for y. Okay. So if I just name this triangle as say O and A and or OPM, let me take OPM. Okay. So triangle OPM is a right angle triangle, and what will be this angle equal to? For an isosceles triangle, if you drop a perpendicular from the vertex to the base, onto the base, the vertical angle, the apex angle will be bisected. So this will be pi by n. And this will also be equal to pi by n. Okay? So, with respect to this angle, what is this y by 2? Which side is y by 2? It is the opposite side. And this is the adjacency. And of course, this x is the hypotenuse, opposite to the right angle. So, opposite over hypotenuse if we take, because opposite is y by 2 and hypotenuse is x. We do not know anything about the adjacent, so we will not be taking the adjacent side. We will be taking the opposite and the hypotenuse. So what is opposite over hypotenuse? It will be sine. Sine of which angle? In this case, pi by n. Okay. So what are we getting? We are getting y over 2 is equal to, okay, let me write y over 2. In place of opposite, I am writing y over 2. Divided by, in place of hypotenuse, I am writing x. Is equal to sine pi by n. So y over 2 is equal to x times sine pi by n, or y is equal to 2x sine pi by n. Okay. So this is the working of the subpart C shown. Let me write shown above. Okay. Moving on to the next subpart. Consider a n-sided regular polygon such that A is equal to P, and the question for the subpart D is use the results from parts B and C to show that A is equal to P equal to 4n times tan pi by n. This is the result of B, that was subpart B had asked us to prove that or get the area of one of the isosceles triangles, which we had found to be equal to this expression. And subpart C had asked us to show that y was equal to 2x times sine pi by n. So I have brought in these two results. And using these two, we have to prove that E equal to P equal to 4n times tan pi by n. We are seeing both of them are having sine function. We are not having any tan function. By just seeing that we are having only sine function in these two equations or expressions, how to come to tan function, and do not panic. Over here we are having 2 pi by n, and this is 2 pi by n. So sine 2 pi by n can be written as 2 sine pi by n and cos pi by n, because we need the argument, the angle, as pi by n. So we can convert 2 pi by n to pi by n. That will not be a problem. So we are having sine over here, we are having tan, but let us start. Let us start. We don't think, don't just panic, don't just get nervous and think how to get the tan function. Okay, let's start. If we don't start, how we'll never be getting the tan function, or we'll never be getting anything. Okay, so start, try. If you cannot get, then you have to leave. But why shouldn't you be trying? Why shouldn't just by looking at, by reading the question, why should you be assuming that, oh, I don't know how to get to tan function, so, and it is containing 7 marks. So there is sufficient reason to worry that it will be a very difficult and challenging question, no doubt about that. That is why it is containing 7 marks. Don't think all of these. Just start. Start with your answer. Okay. They have said A is equal to P. And what is A and what is P? A is the area of the insided regular polygon, and P is the perimeter of the insided regular polygon. Okay. And this AT is the area of one of the n number of isosceles triangles. Okay. So what will be the area of the insided regular polygon? It will be n times AT. So A is equal to n times AT, which is equal to n times half times x squared times, let me write 2 sine pi by n cos pi by n, because I have to come to the angle pi by n. So I'm writing 2 sine pi by n cos pi by n. And these two will be getting cancelled. So we are having this expression for A. And what is the expression for P? You remember the isosceles triangles, the two equal sides were each equal to x units, and the third side was equal to y units. So the perimeter of the insided regular polygon will be, there will be n sides. Each side is having y unit length. So the perimeter is n times y. So perimeter is equal to n times y. And what is y? Y is this. N times 2 times x times sine pi by n. And since A is equal to P, we will be equating these two expressions. Therefore, n x squared sine pi by n cos pi by n is equal to 2xn sine pi by n. Okay, fine. So over here also we are seeing that we can cancel n, we can cancel sine pi by n, we can cancel one of the x. So we are having, even now we are not getting the tan function. Okay, we have not come to the last step. So there is hope. So we can say, and one thing, now getting this expression, you mean me thinking after this, in which direction should we be going? It is x times cos pi by n equal to 2. Then what do we do? This equation, what should we be getting from out of this equation? Or should we be substituting something in this equation? What should be our next step? That will be the relevant question. We have got this, but what is our next step? What should be our next step? For that, you see, you have to come to this expression. We have equated A is equal to P, and we have come to this expression. X times cos pi by n equal to 2. And this is, of course, not equal to 4n times tan pi by n. We are not having n, we are not having tan. How to come to this? See, one thing, we are not having these definitely, but we are having one thing that is not present over here. That is x. Cos pi by n, we are not having the cos function, but at least the angle is the same, pi by n. But what is definitely strikingly different is the presence of the x. X is not here in the given expression. So we have to somehow eliminate x from our this expression. We can we eliminate x? No, we cannot eliminate x, but we know we have to eliminate x. So why not get the expression of x so that we can substitute the expression that we will be getting in place of x in some other equation? Okay, so we write x, and just rewriting this, x times cos pi by n is equal to 2. So x is equal to 2 times cos pi by n. Okay. Now you can substitute this x value in any of these two. You can substitute in place of a in this expression or in this p expression. I would prefer this p expression, but because this is containing only x and this is containing x square, so I have to square it. Let's not go for squaring. We can go for squaring. There's no harm in that, and it is a very easy expression, 2 over cos pi by n. So x square will be 4 over cos square pi by n. Okay, it is very easy. I am preferring P, you may prefer A also. So let me just write the P expression once more. P is equal to 2xn sine pi by n. P was equal to 2xn sine pi by n. And in place of x, I'll be writing this. So this is 2 times 2 over cos pi by n times sine pi by n. Now I think you are seeing the tan function. This is sine pi by n over cos pi by n, which will be tan pi by n. Okay, and there should be the n also. So this is equal to 4n tan pi by n. Show that A equal to P. We had taken A equal to P and equated those two expressions equal to 4n tan pi by n, and we have shown this and we have got 7 marks. Okay. So we have completed subpart D. Let us move on to subpart E. The Maclaurin series for tan x is x plus x cube over 3 plus 2 times x to the power of 5 over 15 plus dot dot dot. Subpart E question is having two more subparts, I and II. The I is saying use the Maclaurin series for tan x to find limit n tends to infinity 4n times tan pi by n, and we had seen 4n times tan pi by n. This was the expression for the perimeter and for the area of a insided regular polygon, right? So fine, they have given us the Maclaurin series of tan x, and we are having tan pi by n, and it is containing just 3 marks. Okay, if by seeing the how many marks does a question contain, you judge the difficulty of the question, then you should be relieved that by seeing that it contains only 3 marks, so it shouldn't be a really difficult question. Okay, it will be fairly simple to solve. So let us try. So actually, the question, the number of marks does not actually always reflect, though it is an indicator, but of the question may be lengthy or it may be a slightly more challenging if the marks that it carries is more, but it is not always true. It is not always true, because I have many students who say that, man, the questions which carry 1 mark, we find those to be the most difficult ones. So it depends from person to person, from student to student. Okay, so we are not going into that argument. Let us focus on answering this question. Tan x is x plus x cube over 3 plus 2 times x to the power of 5 over 15 plus dot dot dot, and we need tan pi by n. So what will we be doing? We will be substituting pi by n in place of x. Okay, simple. So tan, let me just write the whole thing. Limit n tends to infinity 4n, and then the first term is x, so it will be pi over n. Second term is x cube over 3. So x cube is pi over n whole cube. Over 3 means divided by 3 or multiplied by 1 over 3. Plus 2 over 15. So let me write 2 over 15 first. I could have written 1 over 3 previous to this pi over n whole cube as well. So this is 2 over 15 times pi over n to the power of 5 plus dot dot dot. Okay. So this is limit n tends to infinity. Now I'm opening the, okay, before opening the bracket, let me write one more step. This is pi over n, sorry, plus 1 over 3 times pi to the power of 3 over n to the power of 3 plus 2 over 15 times pi to the power of 5 over n to the power of 5 plus dot 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 equal to limit n tends to infinity. Now I can open. I can open this bracket. I can just multiply each term by 4. And so the first term will be 4 pi. Second term will be 4 over 3 pi cube over n square. Third term is 2 over 15, not 2 over 15 rather. 4 times 2 is 8. 8 over 15 pi to the power of 5. Let me put the multiplication signs. N to the power of 4 plus dot dot dot. Okay. So I can separate the terms. Limit n tends to infinity 4 pi plus limit n tends to infinity 4 pi cube over 3n squared plus limit n tends to infinity 8 pi to the power of 5 over 15 n to the power of 4 plus dot dot dot. So the first term is not having any n's, therefore the limit is not applicable. This is equal to 4 pi. And for all the other terms, limit n tends to infinity, because for all the other terms n is in the denominator, and if the denominator of a fraction is a very large number, what is the value of a fraction? It is a very small number. So if the denominator of a fraction tends to infinity, then the value of the fraction will be tending towards 0. Okay. So these will be, all the other terms will be equal to 0. Equal to 4 pi. This is the answer for subpart I of subpart E, and we have got the 3 marks. Subpart I, this contains just a single mark. Interpret your answer to part EI geometrically. Now, as I've said, this was the expression for the area or perimeter of a n-sided regular polygon. And they have given limit n tends to infinity. What is the meaning of limit n tends to infinity? Means you are having means it is an n-sided polygon, and if this n is approaching the infinity, that means let me just draw this I and I can go to this thing, a circle, and let this be the center of the circle. It will not be an accurate diagram. It is a rough sketch, but let me first of all get big triangles. Okay. 1, 2. Okay. Fine. So let us assume these are under, and we have to, these are all isosceles triangles. Okay. And it is a pentagon, 5-sided polygon, regular polygon. I have tried to draw a regular polygon. So it is a regular pentagon. And according to the question, these will be each equal to x. And this is y. Okay. And we are having 5 sides. So this straight line, this third side is definitely not matching with the arc, with this arc. But now if I take the polygon, sorry, not the polygon, but the isosceles triangles to be, if I increase the number of isosceles triangles and I take one isosceles triangle as this one, then you see the third side is almost on top of the arc of the triangle, arc of the circle, that small arc portion. It is, even now, it is not totally on top. As we increase the number of isosceles triangles, as we go on increasing the number of isosceles triangles, the third side of y unit's length, goes on decreasing. And as the y units go on decreasing, that third side becomes almost equal to on top, or just gets on top of the arc line. They are just getting superimposed. The third side of the triangle is no longer remaining a straight line. It is remaining a straight line for that very small arc length that can also be considered as a straight line. So we can think that as n value is increasing towards infinity, that means you are having infinite number of isosceles triangles, then the third side will be almost equal to 0, means a very negligible length. that third side with a very negligible length will be exactly coinciding with that small arc length. So that means in that case, the perimeter, if we just add these two, not if we just add all the third sides of all the n number of isosceles triangles, we will be getting the perimeter of the circle. Because the third side, all the third sides taken together, each third side is now coinciding with a small arc length. So all the third sides of all the n isosceles triangles taken together will be giving us the perimeter of the circle. Okay? And we know the perimeter of the circle and area of the triangle, area of the polygon is equal to the perimeter of the polygon. That is the condition that we are considering throughout this question number 2. So as n tends to infinity, we can say that the insided regular polygon is becoming a circle. Okay? Insided regular polygon is becoming a circle. And the area of the circle will be equal to the area, the perimeter of the circle. What is the perimeter of the circle? It is the circumference of the circle. Okay, so let us write that. You get this diagram and you can see as n tends to infinity, the y tends to 0 or y becomes the y measurement of the length of the third side of any isosceles triangle becomes too small and it coincides with the circle arc. Okay. Therefore, as n tends to infinity, the insided regular polygon becomes a circle okay, and area of the circle is equal to pi r square and perimeter of a circle equal to the circumference equal to 2 pi r. Okay. Since area is equal to perimeter, therefore pi r square will be equal to 2 pi r. We can cancel these two and we can cancel this. So, which gives us r value as 2 units. Therefore, as n tends to infinity, the insided regular polygon with the condition A equal to P. This is important. This will not be true for every insided regular polygon, but those polygons where for which A is equal to P. Okay, will tend to become a circle of radius 2 units. Therefore, E is equal to pi r square is equal to 4 pi unit square P equal to 2 pi r equal to 2 pi times 2, that is 4 pi unit square. Why I am writing this? Because we had got the limit expression to be equal to 4 pi. As n was tending towards infinity, we found the area expression or the perimeter expression that we had found. That was 4n tan pi over n. Let me show you once more. 4n times tan pi over n as limit n tends to infinity is equal to 4 pi. And what is the geometrical interpretation of this? This is, the meaning of this is as n tends to infinity, the insided regular polygon becomes a circle, and circle with condition, let me write with condition equal to P. Because this is vital. If this is not there, then it will be a circle. Inside it, regular polygon will become a circle. So let me not add the with condition part over here, because the with condition part has to be included when the radius is becoming equal to 2. We are getting the radius equal to 2 by equating these two. So when n is tending towards infinity, the regular polygon is trying to become a circle. That is definite. But when we are imposing this condition that A is equal to P, then the radius of that circle is equal to 2 units. So the area is 4 pi units square and the perimeter is also 4 pi units square. Okay. So we are done with the subpart E, but this was not the last subpart. So let us move on to the next subpart. Okay. Consider a right angle triangle with side lengths A, B and square root of A square plus B square. Right angle, so square root of A square plus B square. This is the hypotenuse. Where A is greater than or equal to B such that A is equal to P. The area of the right angle triangle is equal to its perimeter. Subpart F question is show that A equal to 8 over B minus 4 plus 4. Okay. Where to start? We are having only this condition, so let us start with this condition. This is the only equation that we are having. Fine. So what type? It is a right angle triangle. So what type of a triangle will it be? Like this. A will be greater than or equal to B. I have taken A to be greater than. It can be equal to as well. If A and B are the same, then this angle will be equal to this angle, means each will be equal to 45 degrees. But I have taken the general case A is greater than B. Okay, and this one is A square plus B square. So what is the perimeter of this? Area of this? Area is half times AB. A times half AB. This is the area of this triangle. And what is the perimeter? Perimeter is A plus B plus square root of A square plus B square. Okay. So we have to come to this. At least I do not know how to come to that at this moment, but I know A is equal to P, so I will be equating them. Fine, so I am equating this. Half AB, how many marks does this contain? Again 7 marks, okay. Half AB equal to A plus B plus square root of A square plus B square. And I can keep the square root part on one side of the equal to sign and get all the other terms to the other side. So I can write this as, because I want to get rid of the square root. I don't like square roots. I like square roots, but I try to avoid them as much as possible. So half AB minus A minus B. Okay, this can be written as half AB minus A plus B. Why am I doing this? I'm showing you. You may keep this as it is, but in case you want to use the identity, then it will be helping you if you group them. Because you do not know what is A plus B plus C whole square identity, you don't know. So you can write that in that form. And now I will be squaring both the sides, so it will be A square plus B square is equal to half AB minus A plus B whole square. Okay. That is what I was saying, that if you take them separately, there will be three terms and you do not know how to expand a plus b plus c whole square. If you can manage, no problem. You can keep them separate. Else you get it in form of two terms. So this is, I'm just expanding the right side because we don't have anything else to do to the left side. This is a minus b or x minus y whole square, which will be equal to x square. So that is half ab whole square, which is 1 over 4 a square b square, x square plus y square, so a plus b whole square, minus 2xy. So minus 2 times x is half ab, y is a plus b. So this is 1/4 a square b square. Now I am expanding. This will be a square plus 2ab, or a square plus b square plus 2ab, whatever you want, you may write that way. And this will be ab times a is a square b. And ab times b is ab square. And you see a square plus b square, you are having a square plus b square on the left side, and we are having a square plus b square on the right side, so we can cancel them. And now, since we have to get the expression for a, okay, let me just rewrite this once more. So it is half, not half, 1/4 a square b square plus 2ab minus a square b minus ab square. 1, 2, 3, 4, yes, is equal to 0. And we are seeing each of these four terms contain a or a square. So let us divide the entire equation by a. It is 1/4 ab square plus 2b minus ab minus b square is equal to 0. And now these are the two terms containing a, so I'll be grouping them. I'll be taking the a out as a common factor. It will be 1/4 b square minus b, and this should be equal to b square minus 2b, which is b and b minus 2. And this part can be simplified as 4 becomes the common denominator, and it is b square minus 4b is equal to b times b minus 2. Therefore, a is equal to 4b times b minus 2 over b square minus 4b. And from the denominator also I can take out b. So it is 4b b minus 2 over b times b minus 4. And what are we having as the A expression? A is equal to, we are having two terms. 8 over b minus 4 plus 4. Now we have got the b minus 4 in the denominator. So we are having some hope. We understand that we are on the right track. But we are having a single term. We have to get two terms. A equal to 8 over b minus 4 plus 4. So A is equal to, let me rewrite this. I'm just expanding. This is 4b minus 8 over b minus 4. We need plus 4. We need plus 4. How can we have a plus 4? We can have a plus 4 because we are having the common denominator as b minus 4. We can have a plus 4 only if we have 4 times b minus 4 over b minus 4. These two will be getting cancelled and we will be having plus 4. Okay, so 4b minus, if we just expand this numerator, we will be having 4b minus 16 over b minus 4. Okay, so we should be having this in order to get a plus 4. 4b minus 16. Clear? We are not interested about the denominator. We have already got b minus 4. Let us forget about the denominator. We are now interested in the numerator. What will be the numerator? How to get the two terms from a single term. So for that 4 to come from a single term, how to separate the single term into two terms and how to have that integer 4. That 4 can be got only if we have 4 times, 4 is 4 over 1 and we are multiplying the numerator and the denominator by b minus 4. So this becomes 4b minus 16 over b minus 4. Okay. So we have seen that we need 4b minus 16. So since we need 4b minus 16, I will be writing 4b minus 16. 4b minus 16. And since I am writing minus 16, I have to add plus 16 because otherwise the value will be getting changed. I needed 4b minus 16, so I have written 4b minus 16. But since I have added minus 16, I have to add plus 16 as well. So plus 16 and there was minus 8 over b minus 4. You can do it in some other way also. I am getting it in this way. You have to, the expression has been given to you. They have given you the condition A equal to P, the area of the triangle is equal to the perimeter of the triangle and the side lengths are A, B and square root of A square plus B square. Now it is up to you to decide what calculation you will be doing, what simplification, what all arithmetical operations you will be doing in order to get the expression of A that has been given to you. Okay. So now I write 4b minus 16 over b minus 4 plus 16 minus 8 is 8. 8 over b minus 4. So this one is, since 8 over b minus 4 is written in front, or I can just write it in the next step. So A is equal to, I'm writing 8 over b minus 4 in front because they have given this term in front. And this is 4b minus 4 over b minus 4. So A is equal to 8 over b minus 4 plus 4. Okay, this completes the part F. You may consider this to be a lengthy question, but definitely you won't be saying that this is a difficult question. So that for the question number 1, it contains 27 marks. This is containing 28 marks, and the total time is 1 hour. You may be taking more than 30 minutes for answering the question number 1 because you had to draw so many graphs. You had to sketch 2 of them, and for others, you had to see the pattern of those graphs in your calculator. That took some time. But over here, you don't have to think much. The thought process will not be taking much time. You will be just starting to write, and the calculations, the workings are not so very difficult. So you don't have to think much. You write fast and you will be able to complete. Okay. So we have completed subpart A. Moving on to the next subpart. Now coming to the last subpart of this question and of this paper, it is subpart G, and it is containing 2 further subparts I and II. The I says find by using the result of part F or otherwise. The part F result was E was equal to A is one of the side lengths of the right angle triangle. And we had found A to be equal to 8 over B minus 4 plus 4. So by using the result of part F or otherwise, determine the 3 side lengths of the only 2 right angle triangles. Okay. Only 2 right angle triangles, and they will be having this condition as well. A is equal to B, and there is another condition that A is greater than or equal to B. And A, B, A and P, they will be integers. Okay, fine. So they have asked us to use this result. We may not use this result as well. We may give the side lengths of the 2 right angle triangles without using this result. We have that option with us, but let us take that. Let us use that result. So A is equal to 8 over B minus 4 plus 4. Now, since A is the length of one of the sides of the right triangle, this should be greater than 0. No doubt about that. Okay. Now, when can A be greater than 0? When both this is plus 4 greater than 0. If this is a positive number, then of course positive plus positive will be a positive number. So A will be greater than 0, definitely. So let us and also we can have 8 over B minus 4 to be a negative number. Let us first of all start with negative. Then we can go to the positive section. Let us start from the negative. Okay. So what values can 8 over B minus 4 have if this be a negative number? If 8 over B minus 4 is less than 0, less than or equal to 0, let me write, then eight over B minus 4 can be equal to 0, or 8 over B minus 4 can be equal to negative 1, because 4 minus 1 will be 3. Again, 3 A equal to 3, a positive number, can be taken. Or 8 over b minus 4 is equal to negative 2. Then 4 minus 2 is 2, again a positive number can be taken. Or 8 over b minus 4 is equal to negative 3. So 4 minus 3 is 1, again a positive number. So a can have a value of 1. But we cannot have 8 over b minus 4 equal to 4. Negative 4. Because if 8 over b minus 4 is equal to negative 4 plus 4 will be giving a 0 value for a, which is not valid. A cannot have a value of 0. If 8 over b minus 4 is equal to negative 5, then 4 minus 5 will be negative 1. A cannot be a negative number. So, 8 over b minus 4 can have a value of 0 or negative 1 or negative 2 or negative 3 or positive numbers. Okay. So, let us see if we can get any valid b value from these four conditions. Can we have 8 over b minus 4 equal to 0? Because the numerator is 8. This denominator will not be equal to 0. Then how can we have the fraction value equal to 0? A fraction can have a 0 value only if the numerator is equal to 0. So this cannot be taken. This cannot be taken. 8 over b minus 4 equal to negative 1. 8 over b minus 4 is equal to negative 1. Then that means what? So this means that 4 minus b minus 4 times negative 1 is 4 minus b is equal to 8 and b is equal to 4 minus 8 which is equal to negative 4. B is also a side length. So we cannot have b to be a negative number. This is also rejected. Coming to the third subpart. This is minus 2b plus 8 is equal to 8. That means b is equal to 0. Rejected. B is a side length. Cannot be equal to 0. And this one, minus 3b plus 12 is equal to 8. So minus 3b is equal to 8 minus 12 is minus 4. B will be equal to 4 over 3. And they have said A, B, area, perimeter, all will be integers. So we cannot take the b values, though it is a positive number, but it is not an integer. So this will also get rejected. Clear? So we cannot take 8 over b minus 4 as equal to 0 or negative 1 or negative 2 or negative 3. That means we have to take 8 over b minus 4 as a positive number. Okay. So 8 over b minus 4 is greater than 0. Okay. How will 8 over b minus 4 be greater than 0? The numerator is greater than 0. If the denominator is also greater than 0, only then the fraction value will be greater than 0. Therefore, this implies b minus 4 is greater than 0. That means b is more than 4. Let us take the b should be an integer. So let us take b as 5 and see what happens. If b is 5, 5 minus 4, 1 is greater than 0. Okay. If b is equal to 5, then b minus 4 is greater than 0. This condition is getting satisfied, but what is the value of a? Is it an integer? A is equal to 8 over b minus 4 plus 4. Okay. So this is 8 over 5 minus 4 plus 4. 5 minus 4 is 1. 8 over 1 is 8 plus 4 is 12. So a is also an integer. B is an integer. A is an integer. Let us see. And the triangle is like this. This was A and this was B. This was the right angle. So if we take A as 12 and B as 5, let us see what happens to the area and the perimeter. They should also be integers. So area is equal to half times 5 times 12 equal to 30. Definitely an integer. What is the perimeter? Perimeter equal to B is 5, A is 12 plus A is 12. So 12 square is 144. 5 square is 25. So this is 5 plus 12 is 17 plus 144 plus 25 is 169. Square root of 169 is 30. So this is 30. A is equal to P. And they are integers. So we can take one of the right angles to be equal to having the side lengths as 1 right angled triangle can have side lengths as 12, 5, and A is greater than B. So 12, 5, and A square plus B square, it is 13. Okay. So we have got one of the two right angle triangles. What is the second one? Let us try 6. We have started with 5 because the numerator has to be a positive number. Let us take the very next value of the integer value 6. 6 minus 4 is 2. 8 over 2 is 4 is positive. Okay. So let us try. Not only positive, it is an integer. So if b is equal to 6, then 8 over b minus 4 is equal to 8 over 6 minus 4, which is equal to 4, that is greater than 0. Therefore, a will be equal to 8 over B minus 4 plus 4, which is equal to 4 plus 4, that is 8. So B is equal to 6 and integer A is also equal to 8. A is 8, another integer. What about the area and the perimeter? The area and the perimeter, this is 8, this is 6, and that is 6 square plus 8 square, which is equal to 10. So A is equal to half times 6 times 8 equal to 24, and perimeter is equal to 6 plus 8 plus 10, 14 plus 10 equal to 24. See, A is equal to P. Therefore, the second right angle triangle will be having side lengths as 8, 6, and 10 respectively. A is greater than B. Sorry. Okay. Yeah. So these are the two right angle triangles that they had asked for. And the I says it contains just 1 mark. Determine the area and the perimeter of these two right angle triangles. We have already calculated them in order to check whether they are integers or not. So for the first right angle triangle, you don't have to do the calculation again because you have already shown how you have got these values. A is equal to P is equal to 30. And for the second right angle triangle, P is equal to P is equal to 24. Okay. So we have completed this whole paper 3. Okay, okay. So thank you for staying with me till the end. And now we have completed all the 3 papers of time zone 1. Next, we will be starting with paper 1, time zone 2 of May 2021, IB Math AHL, of course. Okay. So in our next session, we start with paper 1, time zone 2, May 2021. And Let me give you a brief introduction of mine. I am Nilanjana Sanyal and I tutor IB Math A, HL and SL students of IB Math AA actually, HL and SL students from India and from outside India. And I'll be starting my group online math tutoring sessions from the month of July. And it may be from the end of June or from the month of July. And if any of you is interested in joining my classes, you may contact me. You are seeing my website, you are seeing my email ID, you are seeing my WhatsApp number. You can mail me, you can text me, you can contact me for more details. Okay? So we'll be meeting very soon in our next session. Till then, bye.